Hi, good morning, everyone. My name is Carlos Leon, and I will share with you some thoughts and reflections about the life cycle circularity assessment methodology we are working on. It's for me, it's a pleasure to be here talking about this matter because we think that it is very important for the future at the time when you are consider and designing new products and services, or you are thinking about changing any feature of your product or service. So let's go. First of all, let me introduce myself. I am our company. Um, I am a mechanical engineer with advanced studies in materials and manufacturing. In the past, I was working for a wind turbine manufacturer that it is called today Gamesa, and it's merged to Siemens. And at that time, I was working in the technology department. I was doing different kind of activities like product design, strength analysis. I was leading a group of the structures section, and also I manage technology development projects and some product development projects. And at the end of my time there, I was working in a small group called technical audit members, and we developed different procedures and processes to design products. At the end of 2014, I started to think about circular economy, and with my um, colleague Rebecca, we founded Sustain, that it is a consulting company, and we help companies and administration, public administrations, and other kind of organization to implement circular economy principles to develop truly sustainable products and services, trying to consider the triple dimensions. So we offer different kind of services. We do some training and dissemination activities as well. And we have been working on the development of different kind of methodologies related to circularity assessment in the past. You can have more details in my LinkedIn profile, and you already have the Twitter, um, Sustain, and myself, and your email if you have any doubt in the next future. Just a brief description of our services. We are developing services in four main in four axes, like it's assessment, trying to identify risk and opportunities of the implementation of circular economy, and doing circularity assessments and working about helping companies um, to work on circular compliance. The second axis is the related to the life cycle, and we work with eco design and design for a circular economy. And we are working a lot about the life cycle sustainability assessment and life cycle cost assessment, life cycle assessment, um, related to environmental impacts and social life cycle assessment as well. And we work also about strategy, trying helping companies to define their strategies towards the circular economy and sustainability strategies as well. And the fourth axis is related to reporting. So we help the companies to communicate their positive impacts. And finally, as I mentioned before, we do some training, work service, and dissemination activities. I've been working as a circular economy mentor and professor as well, so we have some experience on that. So about the talk today, I would like to share with you how we see the development of life cycle circularity assessment methodologies. In order to do that, I will share my reflections and my thoughts about the context analysis and the circular economy implementation, and describe also two main concepts that we think that we have to consider to build this kind of methodologies, like that is the life cycle concept and life cycle sustainability assessment. Finally, tell you which is our approach to build this methodology, and finally, which are the conclusions we are and the general evidences we are finding in the, let's say, in this process of building this methodology. So regarding the context analysis, the recent years there are a lot of news and research activity and publishing about different kind of concepts related to sustainability and circular economy. As you see in this picture, the sustainable development and circular economy in the upper right part of the picture are more concepts related to philosophies and applicable to society or to the global economy model. Today we are going to talk about life cycle management, um, LCA, and general life cycle thinking, because we have to build a methodology to design better products and services. So we are thinking, and we are so focused with this methodology for the design of products and services. So it's more related to eco-design, but it is related to assess that the product that or service mainly applicable to products, it's applicable to assess if this product is more circular or less circular than the other, or if the product that we are designing is more or less sustainable. So you already perfectly know the butterfly diagram from Ellen MacArthur Foundation, and it's very important for us that to keep in mind these three main principles, the butterfly diagram, because we are gonna consider them for the development of the methodology. The first one is try to design the products regenerating natural systems. The second one's we have to try to keep products and materials in use, whether if we are using biological materials or we are using technical materials. And finally, the third principle is related to design out waste and pollution. So those principles are to be deployed in a kind of bunch of circularity indicators um, in order to consider fully circular economy implementation. Okay. So at the end, this diagram can be translated in a kind of this transition from a linear model to a circular model. In the Ellen MacArthur diagram, it's a general diagram. So at the end, any kind of product that we need to design, it's a sequence of operations where we are consuming a different kind of materials and resources, and we are generating a different kind of waste or wastewater, different kind of waste in order to deliver this product to the distributor or the consumer, the final user as well. So at the end, with this methodology, our aim is to assess how is the transition from a linear model to a circular But at the end, life is a little bit more complicated than that general diagram. So at the end, in a, if we are thinking about a complex product, we can have hundreds or thousands even of operations with a lot of different materials and resources like water or energy that we are consuming in every operation. In every operation as well, we might say generate some kind of scraps, different kind of waste, hazardous waste, wastewater, and this is the sequence in which the product is advancing in order to get the final product. So at the end, if we are thinking about a linear model, this could be a representation of, let's say, development or value chain of this product. At the end, we have to we have to think in this kind of diagram. So imagine that any of these arrows that are coming into an operation, imagine that kind of a particular material, a particular resource is to be coming from a recirculation loop. So, and imagine that any kind of arrow that are coming out from every particular operation of their value chain map could be recirculated as well. So following the different kind of recirculations stated in the McCarthy diagram, we can have a repair loop, we can have a disassembly and take back of the different kind of components and product. We can have renovation or refurbishment for a particular comment. We can have a remanufacturing loop, and finally we can have recycling of raw materials. So we should think about that when we are designing a particular product, we should think that this would be the map. So at the end, we have to assess with this kind of methodologies um, how is the how optimum is this value map. Let's say. So go on with a key concepts to consider in the development of this methodology life cycle. This is a key concept because we should think at the time when we are conceiving a product that the whole life cycle. In the past, we just think that when we were designing a product, we just think in techniques like design for manufacturing or design for, let's say, optimum performance but now we have to consider the whole life cycle, that is the time interval between a product's conception and its disposal. You can see here an international regulation describing what is the life cycle and what is the life cycle cost. The cost assessment is to be included in this methodology as well. So life cycle cost is the cumulative cost of a product over its life cycle. And as you can see, normally we can have 6 major life cycle phases of a product. Like the first one is concept and definition. It includes all the activities related to the requirements definition for the product we have to design, and the conceptual design phase of this product when we are defining the technical solution and we are assessing the cost and the quality and the delivery plans for this product to put it in the market. The second phase is the design and development, where we are designing in detail every component and every part of the product, and we are developing the supply chain as well. The manufacturing phase, of course, is well known. And in the next one is the installation. Some products need some activities to install them, like for example, internet or even if this installation is very easy, like a washing machine in our house. The next one is operation and maintenance. It includes all the activities regarding the use or operation of the product and different kind of maintenance, like preventive maintenance, corrective maintenance, and predictive maintenance as well. And finally, the disposal is the phase when the lifetime of the product is finished, and we have to manage of the waste generated from the product. So another concept we think we have to consider at the time we are building this methodology is the life cycle sustainability assessment approach. This methodology refers to the evaluation of all environmental, social, and economic negative or even positive impacts and benefits in the decision-making process toward the design of more sustainable products, and is to be evaluated. All these impacts are to be evaluated throughout their life cycle. So it was published by the Environmental Program of the United Nations back in 2009. It's a it's a mix of life cycle environmental analysis, life cycle cost assessment, social life cycle analysis in order to assess the social impacts of the product all along the life cycle. You can see a table of different kind of aspects considered in these three parts. Like for example, in the LCA, we have the energy consumption, the natural resources consumption, water use, different kind of emissions we are generating. Regarding the cost assessment, we have, for example, the fuel costs, labor cost, and the cost of the different raw materials we are using in our product, the electricity cost, for example. And regarding the social part, we can assess the wages, the accidents, the child labor, and working hours, and quality of the employees we have in our company. So a little more of detail of these three, let's say, approaches, the life cycle cost assessment. So if we think about the different life cycle phases, we can identify a different kind of cost all along the different phases. Okay? For example, in the concept design and development, we have some development cost, validation cost, engineering hours if we are designing a particular product, the bill of materials within the manufacturing cost, all the cost of the bill of materials and the supply chain development. In the manufacturing area, different consumables we have for manufacturing the product, electricity consumption of fuels used for the manufacturing of the product, and the cost of the machines. And within the installation cost, according to IEC, we can differentiate between transport and installation. So we have to consider all the transportation costs from our factory to the distribution or final users, and finally installation if it applies, of course. Within the operation and maintenance, as I mentioned before, we will have the operational cost that, for example, if I need some electricity to run out my product. These are the costs that the user has to afford, has to pay for. And the maintenance regarding to all the maintenance and repair activities throughout the life cycle of the product. Finally, the disposal, for example, the taxes we have to pay for putting a product into the market, or the different kind of recycling activities we might have finance warranty at the time that we are designing the product, for example. So with this methodology, we can have, of course, the distribution of the cost in the different phases. You can see here an example of a pharma product. It is very important to think that to know that we are measuring the cost per unit of a product all along the life cycle. And with this kind of methodologies, we can have an assessment of different kind of alternatives, the cost of the different kind of alternatives we can have if we are changing particular material, or if we are using a factory to manufacture this product, or if we are thinking about using renewable energy in some operations in the manufacturing processes, or if we are changing the transportation means we have some alternatives of transportation for a distributor or another distributor. All kind of changes you can include in your product. You can check the cost with this kind of methodology, and more importantly, to have life cycle cost per unit of product all along the life cycle. The life cycle assessment, this is in fact the environmental life cycle assessment, is used to assess the environmental aspects associated with a product over its life cycle. There are ISO standards defining how to perform these assessments, and it's very important to define two different concepts. This is environmental aspect and environmental impact. The environmental aspect is any element, activity, product, services of an organization that has an interaction to environment. And environmental impact is any change to the environment, whether adverse or beneficial, resulting from an organization activities, products, or services. For example, in this table example, you can see in the slide for an activity like manufacturing, we have different aspects, like for example, generation emissions to air, or generations to hazardous waste, or and the impact of these aspects could be, for example, air pollution and soil pollution. With this kind of techniques, we can have the impact of the different part of the life cycle of the product in different kind of environmental impact categories. There are ISO standards define how to develop a life cycle assessment, and there are different tools and different methodologies in order to choose different kind of environmental impact categories. And you can see in the slide, for example, the distribution of environmental impacts for three parts of the life cycle of a particular product. The product itself, the product assembled X works, the energy consumption needed to operate this product, and the different consumables you need during the operation maintenance use. But you can have also, let's say, environmental impact in endpoint categories like human health, the damage to ecosystems, and the natural resources consumption of the different kind of parts of the life cycle of the product. In this case, the product, the energy consumption, and the consumable. More and more in the recent years, the life cycle assessment is being used, and in some sectors, it's been developed for different kind of products like washing machines or the textiles or different kind of products. For example, in the automotive section, they're working on that as well. So it's becoming more and more important to have a life cycle assessment of my product in order to know which are the environmental impacts of the product and the different phases of its life cycle. And even from the green public procurement guidelines, for example, the European Union is working very hard on that, and there are some countries asking for that for the green public procurement activities. And finally, the third part of this life cycle sustainability assessment is the social life cycle assessment. It's a technique to assess the social and socioeconomic aspects of the products and the positive, negative potential impacts on their life cycle. These aspects have to be assessed to those aspects have to affect the different stakeholders you have around your company, whether directly or indirectly. The impacts may be linked to the behaviors of enterprises, to socioeconomic processes, or to impacts on social capital. You can see in the slide an extract of a table defining an example of stakeholder categories, impact categories, and those impact categories have to be used to define social impact indicators. Okay, so finally, I would like to share with you which is the approach or the methodology we are working on to assess, as I mentioned before, the circularity of a life cycle of product at the time when we are designing a product. We have been working in a European project called Samwise the last 3 years, and in this project we are working to develop similar methodology to assess the circularity of EPS and XPS products and application. EPS is expanded polystyrene, so it's a kind of plastic used mainly for different kind of packaging, so for the building sector as an isolation, and XPS products is extruded polyestyrenes are used mainly for different kind of packagings in the food industry. So our challenge is in this project is how to prevent EPS and XPS from reaching the marine environment and how to keep it in the system. So for that purpose, we are working on the development of a similar methodology to assess the circularity of the current solutions and the alternative solutions we can have in the next future. So for doing that, we have been working in a state-of-the-art review about all the different kind of references existing nowadays related to circularity assessment of products, plastic products or products in general. And we have seen a lot of research activities. There are a lot of research activities and a lot of papers related to that. Some standards are being developed in the last years, and more guidance and methodology are being published. So it's important to say that well, there are some standards, international standards. For example, there is a British standard and a French standard and a dual standard are very focused on measuring the circularity of an organization, and it's not they are not so related to assess the circularity of a specific product and not related to to assess the circularity of the life cycle of a product. The cradle-to-cradle methodology is defining some aspects to assess when you are designing a product, like material health, measurement, reutilization of materials, the water management and energy management, and it's including the social fairness, as I mentioned before, in the life cycle sustainability assessment. So the conclusions of this state-of-the-art review is that there are no specific regulations by now to perform circularity assessment of the life cycle of products. We haven't found references for specific references, I mean methodology or guidelines for specific life cycle circularity assessment of the products considering the triple dimensions. We have found that we have to consider the life cycle approach, and we have to consider this approach of life cycle sustainability assessment to combine environmental impact, cost impact, and social impact. So, considering that, we concluded that the main principles that this methodology has to consider is that, of course, the life cycle. All the different phases have to be included within this circularity assessment. We have to consider triple impact and the economical, environmental, and social impacts all along the life cycle. And of course, we have to deploy these main three principles from the circular economy: regeneration of natural system, keeping products and material in use in the system, and designing out of waste and pollution. So, with these main principles, we think that the social impact we have to consider as well the sustainable development goals, focus on people, planet, prosperity, peace, and alliances. So finally, the main requirements we have to consider for the development of this methodology are that is to be quantitative, because we think that if you are designing a product, the qualitative assessment is to be as close as possible. Of course, there are some parts that maybe have to be qualitative, but we should work on making them quantitative. It has to be applicable to any kind of product, and it has to be applicable to the complete system. So it has to cover if we are thinking about an alternative material, if we are thinking about using a different waste management system or improving recycling rates of different kind of components or the product itself. And it has to be a decision-making tool, allowing you to perform different kind of trade-off analysis in order to compare product alternatives, including these material alternatives, different product design solutions, or it has to allow you to identify critical parameters in cost, environmental, and social impact as well, and should be prepared to perform sensitivity analysis for the critical parameters. And of course, we have to define circularity sustainability indicators, and we think that it has to allow to search for the optimum scenario for reaching the optimum circularity plus sustainability in the product design. So we are thinking about different methodology steps. So I'm going to go over them briefly. And the first one is to build a value stream mapping of the whole life cycle. The second one is to define these sustainability and circularity indicators. Of course, we have to, in step 3, we have to assess the impact in the 3 dimensions and to identify the critical parameters in every dimensions. As you see in step 4. And finally, you have to measure the sustainability and circularity of your product. Step 6, 7, and 8 it has to allow you to identify risks and opportunities. Risks coming from, let's say, new market trend or legislation, and it's coming in force in 2 years from now, or maybe, for example, uh, change of cost in a particular raw material that has an important impact on your product costs. And opportunities regarding any kind of circularity improvement aspect that you can include in your product. So with these risks and opportunities, you can build different alternative scenarios in order to check the sustainability and circularity of of those scenarios, leading to the optimum scenario that you can have for the requirements or for the legislation requirements you have on the market and technology maturity, the maturity of the different kind of technologies you are using in your product. So regarding the step one, sometimes, for example, if we are thinking about the packaging, we might have just one component, but but sometimes a complex product is composed by hundreds or thousands of components. So at the end, this value stream mapping could be so large and complicated, but we should work on having this value stream mapping as detailed as we can in order to identify all the materials and resources are consuming in different operations and the different waste that we are generating in every operation. For example, and the different energy consumptions in every operation in order to assess afterwards the life cycle, the environmental impact through the life cycle assessment or the life cycle cost assessment, considering the cost of materials, the cost of the different manufacturing operations, the transportation, and the operation and maintenance costs, as well as I mentioned before. So the second one would be the definition of sustainability and circularity indicators. If we are thinking just in circularity, and if we think that the indicators have to be deployed from circular economy principles, we could define, there are a lot of methodologies. Recently, for example, the MacArthur Foundation has published Circularitics, and there are other methodologies and tools are around the world defining different kind of circularity indicators. But if we are thinking about deploying circular economic principles, we can have circularity indicators related to the renewable content in the materials we are using, the percentage of renewable energy in the whole life cycle, percentage of water recirculation. If we are thinking about keeping materials in the system, we can measure the percentage of materials in the system. That matter is not clear at the beginning when you are designing a product. If yes, which combination of recirculations are the optimum situation in order to have a circular product. So it's clear that the reuse or repair is better than the recycling, but sometimes the technology or the materials you are using, and the state of the art of the different materials and components leads you to recycle some components or to remanufacturing some of them as well. So we have to think about the best combination of the recirculation of all the components. Imagine that we have 200 components in our product, so which is the best combination of recirculation and recycling content as well, in order to have the highest, let's say, punctuation in this indicator that is called percentage of materials in the system. We have to think about how circular are the equipments, tools, machines, or installation infrastructure we are using in our life cycle. We have to think about defining requirements for our supply chain, for example, for a machine, and try to include, let's say, circularity or sustainability requirements um, for purchasing this machine, asking for, let's say, percentage of materials to be repaired or reused or remanufacturing or recycling. So this is an important thing. It's if we are using a lot of tools and machines that have to be uh, finally delivered to the landfill, well, I don't know if it is so circular our process. If finally we have um, to dispose of the machines and we are generating a lot of waste at the end. And finally, from third principle, designing out waste and pollution, of course, we should measure the waste generated and the emissions generated all along the life cycle. So at the end, um, circularity has to be sustainable. So at the end, we should define circularity plus sustainability indicators, including, apart from circularity indicators, the economical indicators, environmental and social impact indicators, to have at the end a global circularity sustainability index for the road we are designing, or for the different alternatives we can have at the time that we are designing in the conceptual design phase, which is the best alternative we can have. It's very important at this part, working on normalization and weighing techniques in order to decide, um, first of all, we are comparing a different kind of indicators. We are comparing circularity indicators when we are talking about percentage of materials uh, kept in the system, or waste generated, or emissions generated, or percentage of recycled content of different materials in our components, in our product. We are comparing this with economical indicators, if it is euro or dollar or whatever, and some environmental impacts indicators with different kind of environmental category impacts, and all together with the social impacts at its different magnitude. So we have to work on, let's say, maybe probabilistic techniques in order to normalize all of this, in order to compare all together to have a global circularity and sustainability index. And the second thing that's very important is the weighting of these techniques. It has to be defined, related to the company organization strategy and, let's say, the competitiveness strategy of the company. If this company is competing just for cost, or just for cost and some part of environmental impact issues, or which is the, let's say, the combination of these aspects. So normally we can talk about the quality cost delivery, but if we are thinking about sustainability, it's how the strategy of the company deployed to the circular economy and the circularity and sustainability indicators. So we have to work on that as well in order to have finally, again, representative security and sustainability index aligned with the company strategy. So step 3 is to assess the environmental, the cost and social impact of the product technical solution, and to identify the different critical parameters we have, and maybe in the cost part or environmental assessment as well. Um, so we have seen international regulation defining how to perform a life cycle cost assessment, and ISO standards defining how to perform a life cycle environmental life cycle assessment as well. And there are a lot of studies recently, and a lot of people working around the world about how to measure the social impact of the organization or the life cycle of a product as well. And finally, I mentioned that we have to identify the critical parameters, and step 5 would be the measurement of sustainability and circularity. Imagine, as we can see in the picture, that we can have two different scenarios of circularity with different punctuation of those circularity indicators. So um, I wouldn't know which one is better because first of all we have to combine them in order to have a global circularity index, but it's very related to the environmental and cost and social impact of these different scenarios. So at the end we need to include in this global index circularity, environmental impact, economical and social impact aspects in order to have a representative global index. So sometimes it's easy to say that if you are just using this material is better than the other, but I think we should keep in mind that there are a lot of things around the life cycle that are defining another environmental impacts, and all together we have to think about a global circularity plus sustainability index. And the final steps 6, 7, and 8, you can identify the risks and opportunities I have mentioned before, and you can build different alternatives scenarios like the example you can see in this picture, like the scenario 1 and the scenario 2. Maybe the scenario 2 is changing well, scenario 2 is changing the renewable energy in the whole life cycle, and the content, renewable content in materials, recycled content of different kind of materials, different recirculation all along the life cycle. So imagine that if we are thinking about the packaging that it is made of one or two different materials or three, imagine that we should apply this methodology for a complex product. So it's not so easy to perform a complete circularity assessment or life cycle of a complex product, but we should think about these steps. So if we are thinking about building different alternative scenarios, you can see example of environmental assessment impact, for example, of a product and alternative with LCA assessment. With LCC, life cycle cost assessment, we can have the life cycle cost per unit of a product, considering variations in the different phases of the life cycle, and even some uncertainties in the life cycle if we don't know exactly how it's going to cost this material in the future, or this process, or the energy or whatever. So we can have this sensitivity analysis considering the different uncertainties and costs. So I'm finishing. So our findings within the development of this methodology is that the life cycle circularity assessment should consider circularity indicators based on circular economy principle. Circularity is to be sustainable, so triple dimension impact should be considered. And this LCSA life cycle sustainability assessment approach could be very useful to include this triple dimension methodology. Of course, it has uh, to has the to have the life cycle orientation, and finally that there is a lot of work to do about normalization and weighing of circularity and sustainability indicators in order to measure properly a sustainable circularity. So that's all. It was a pleasure to present to you our thoughts and reflections and developments related to circularity assessment methodology. So I wish it was interesting for you, and we'll be glad to ask your questions in the chat of this talk. So thank you very much, and it was a pleasure, and have a nice day. Bye bye.